a typical numerical where the transfer function GSHS, that is open loop transfer function, is given like GSH is equal to K a square plus 6s plus 10, and denominator is a square plus 2s plus 10. So there are two poles and there are two zeros. Such numerical we have seen in case of real pole and real zero. Here we are going to see that both the poles and zeros are imaginary. So this is a very typical case, and you can expect that this is the highest level of difficulty that can be asked in complex poles and complex zero related numerical in root locus. So you are finding that the two poles are here, that is -1 plus minus j3, and two zeros are here, -3 plus minus of j. These are the two poles, these are the two zeros. So you'll be finding that p minus z is equal to 0. So this is a very important thing. As p minus z is equal to 0, that is 2 pole 2 0. So there will be no asymptotes. That is the first line. That means sigma c, theta c, beta 1, beta 2, beta 3, all these things you will not have to calculate. And if you are saying at any point on the root locus, real axis root locus is absent. So if you check between -0.5 right side, number of pole and 0 is 0. So 0 to -1 is not on root locus. If you check -2 in the right side, total number of pole and 0 is equal to 2. That is total number of pole, even number. And -1 to -3, there is no root locus on real axis. If you check -4, -6, look at the right side. Total number of pole plus 0 is equal to 2 plus 2 is equal to 4, even number. That means -3 to -infinity, no real axis root locus. So these are things you can find out very easily now, and you have to do it fast. So what are the things we have found? There are two complex poles, there are two complex zeros, and real axis root locus is not present, and centroids are not to be drawn, asymptotes are not to be drawn, because we are finding that there is no root locus which will be going to infinity. And if you see what is the characteristic of root locus, it will be one root locus will start from here, that is -1 plus 3j, and it will directly come and dive into -3 plus. Another root locus will start from here, minus 3j, sorry, -1 minus 3j, and it will come and dive into -3 minus j. So these are going to be the root locus. So from here top it will come here, and from the bottom it will come here. So in this case, you will not have to find breakaway point. In this case, you will not have to calculate sigma c, omega c. Case also is not required, because root locus will totally be confined into left hand side of the S plane. That means this is absolutely stable system, and no root locus is going to infinity. So you know the starting point and end points. All those steps are not required. Okay, so only one step is required. What is that? Finding the angle of arrival at these two zeros and calculating the angle of departure from these two poles. That means actually you have to find out what is the angle of departure from this pole, -1 plus 3j, and what is the angle of arrival at this zero, what is that, -3 plus j. That is one angle of arrival calculation and one angle of departure calculation you have to do. Only two calculations and this numerical is over. So comparatively saying, though the processes of calculating angle of arrival and angle of departure is little critical, but actually saying in this numerical you have to do very less work. Okay, so not much work is there, but all these things you have to write logically. That is first step, minus z is equal to 0. Hence, theta c, sigma c calculation not required. As none of the root locus is on real axis, or you will be finding continuously that breakup point is not to be found. In this case, you will be finding centroid not to be found, asymptotes not to be found. Root locus is totally confined in the left of S plane, and it is starting from pole and ending at 0. Omega marginal not to be found, K marginal not to be found. But why? All these things you have to write logically. So the first thing you have to find out, is what is the angle of departure. So angle of departure has to be calculated from 2 points, is -1 plus 3j and -1 minus 3j. But as they are complex conjugate poles, I have to calculate angle of departure only at -1 plus 3j, and that will be negated and put a negative sign before that, and that will be the angle of departure from -1 minus 3j. So first thing, we're supposed to find out angle of departure at -1 plus 3j. So what we find is there are apart from -1 plus 3j, there are two zeros. Okay, so these are two zeros which are present. So join this -1 plus 3j with this first zero. Join this -1 plus 3j with this second zero, and there is another pole. So join this -1 plus 3j with the pole which is kept at -1 minus 3j. This is the first time we are including angle of departure, we are doing the angle of departure calculation where pole angle and zero angle both will be included. So in this case, there will be two zero angle, phi z1 and phi z2. Okay, and there will be one pole angle, and pole angle is directly 90 degrees. So very easily we can visualize it. That phi p1 will be 90 degree, or phi p, as there is only one pole, it will be phi p is equal to 90 degree. Now, how to calculate phi z1 and how to calculate phi z2? So phi z1 you can find, this is the angle. So this is the angle phi z1 to find. This is this point, real axis is -1. This is at -3. So this distance is equal to 2. Okay, so base is for 2. So this is that angle, base is 2. So I suggest that you draw this root locus and all this thing by using graph paper, simple graph paper. In case, this angle calculation for base height calculation will be easy for you. But you have to practice this thing beforehand. Only you can do that. So this base angle, base distance, so this is at -1 plus 3. So that means this is a -1 line. So from this -1 up to -3. So this base distance is 2. Okay, and this height. So this is -1 and plus 3j, and this height is 1. That means this height is also 2. So this height is 2, and this base is 2. That means this angle will be 45 degrees. So phi z1 is equal to 45 degree. You can find here. How to find phi z2? So for phi z2 means you have to just find out this height. How much is this height? So this height will be 4. So above ground it is 3, and below it is actually 1. Okay. So this distance is 1, and above it is 3. So this is 3 plus 1. This distance is 4. And how much is base? Base distance remains same because previously base distance was 2. In this case also, this distance will be same because these two zeros are actually complex conjugate zeros. So this will be tan inverse of 4 by 2. That means it will be tan inverse of 2. So tan inverse of 2 we have found previously it is 63.43. So phi p1 is equal to 90, or phi p is equal to 90. Phi z1 is equal to 45. Phi z2 is equal to tan inverse 2. That is 63.48. So 43. 90 minus 45 and whole bracket plus 63.43. So you're finding phi is equal to minus 18.4 degree. And that, if you're doing 180 minus 18.4, you'll be finding it is 198.43 degree. That means from this point, that is -1 plus 3j, you have to draw an angle of 198.43 degree. And how to draw it? It is shown here. So 198.43 means 180 plus 18.43. That means from this negative line, again you have to take an angle of 18 degree. Or from the positive x-axis, you have to get an angle of 198.43 degrees. So this is how the angle of departure is to be drawn. So you have to connect this, and you can draw this. This is the angle of departure. Okay, that means whatever root locus is coming from here, this will leave this pole -1 plus 3j by making an angle of 198.43 degree positive. Okay, so this is 198.43 degree positive. And same thing if you are doing here. So below -1 minus 3j, this will be having minus 198.43 negative. That means it will be going upward. 198.43 means it is like this negative. From here you have to come minus 198.43. That means it will go up. So this will be minus 198.43. Please, I'm asking you, practice all this thing, how to draw 190, 130, 135, 200, positive as well as negative. You practice it. Logic being, here from the positive side, if you are going anti-clockwise, it is positive. So from positive x-axis, if you are going anti-clockwise, this is 90 degree. Again, you are coming here, this is 120 degree. Again, you are coming here like this, it is 270 degree. And again, you are coming here, this is 360 degree. So if I ask you 400 degree, 400 degree is actually 400 minus 360 minus x, that is actually 40 degree. So that means it will come in the first quadrant. So if you are going, starting from the positive x-axis, if you are going in the anti-clockwise direction, that is actually positive axis. And starting from the x-axis, if you are going in clockwise direction, so anti-clockwise direction is positive and clockwise direction is negative. So now I'm asking you to draw minus 198 degree starting from this pole. That means you have to draw this line, and minus 190 you have to come clockwise, and you have to go in this quadrant, up quadrant, okay, and you have to draw the root locus like this. So please practice this. Without practice, all these things are not possible. So what I have done first is I have found from the first pole or first imaginary pole, that is -1 plus j3. From there, first I have found what is phi p minus phi z, and there are two phi z. So this is phi z1 angle. First thing, so this base is 2, height is 2, so that means this angle is 45. And for the second zero angle, you are finding base is 2 but height is 4. That means this will be tan inverse of 2. That means this angle will be 63.43. And this angle phi p, this will be 90. So what is phi? 90 minus 45 whole bracket 63.43 minus 18.4 degree. That is phi. How much is phi d from minus 1 plus 3j? It is 180 minus 18.4. We are getting plus 198. So if you're drawing plus 198 point degree, it will be coming in the third quadrant. That means from this minus 1 plus 3j, it will be coming toward this pole, sorry, to the 0, which is given as z1. Samely, if we can say about this minus 1 minus 3j, this angle of departure will be minus 188.43. That is, that will be going towards this phi z2 or z2, which is given as minus 3 minus j. Okay, so it is like this. And then what we are supposed to find out is angle of arrival. Same thing you have to do, but in that case, you have to use this diagram. Okay, so now this is minus 1, sorry, minus 3 plus j. Now there are two poles and one zero. So whenever you were looking for this pole, there are two zeros and one pole. But now you are finding angle of arrival. That means starting from the pole minus 1 plus 3 0, whenever it is entering the 0 which is there at minus 3 plus j, in which angle it will enter this 0. For that we have to find angle of arrival. So for that we have to connect first. We have to first find what is phi z. So phi z and phi z1 and phi z2, they are having angle of 90 degree. Same way we had found out previously phi p1. Okay, that means phi p1 and phi p2, they have an angle of 90 degree whenever you are calculating from phi p1 to phi p2. Okay, phi p2 to phi p1, if you are finding, it will be 270 degree. So now you are finding the same thing, that is phi z1 up to phi z2. So first join this, and with respect to this base angle, it is coming to be phi that is 90 degree. Now very important thing, or very difficult. Now you have to join this phi z with phi p1. And this joining line, how much angle it is making with respect to the real x-axis. So first you have to find out phi p1, then you have to find phi p2. So how to find phi p1 from phi z1? Okay, so from z1 how to find phi p1. So from here z1 join this phi p1. Okay, and this angle is actually phi p1. And you are finding it as a third quadrant, so this will be something more than 180, and how to find that. So for this angle finding, you have to first calculate this angle. Okay, so you have to first calculate this angle. This is how you are finding it, and this will be the height then. Okay, so this will become height, and this will become this. So how much is this angle? How much is this distance now? So this is minus 3 plus j, and this is actually minus 1 plus 3j. This distance. you have to find this angle. So whenever you're finding this angle, what you have to see is this is the base. Okay, so this very simple geometry, but you have to understand this is the base. So how much is this height? So this height is this is 3 J3. Okay, so this is J3. That means from here this height is actually 2 units. Okay, so from this is actually 2 units, and then from here this is also, so from -1 to -3. So this is also 2 units. Okay, that means this angle, if you are calculating, this angle will be actually 45 degree. That means this whole angle will be 270 minus 45. So that will be coming around 270 minus 45. That means this will be coming around 225 degree. Okay, so you are finding that arriving at 0 minus 3 plus j is at an angle of 431 degree. So how to find this 431 degree? So go to the previous page first. Go to the previous page. So it has been shown here. Okay. So we are trying to find what's the angle of join angle. So join poles at zeros to -3 plus j1. That means first pole, first join this -3 plus j. From here you join this. Okay. So this angle is going to be 5p1. And then from -3 plus j you join this one. Okay. This pole 2, which is at -1 minus 3j. That means this angle, this whole angle. Okay, so from here to here this is thing, and from here to here actually this angle we have to find as 5p2. So 5p2 angle is shown here wrong. Actually 5p2 angle will be from here to this whole angle. Okay, so this is going to be actually 5p2, and we have calculated it to be 116 degree, and phi z1 phi z1 in that case is coming to be 90 degree. So I will write another page in detail, and I will show you actually how to calculate these angles. Okay, so 5p1 you are finding 225. I told you how to calculate that. So first you have to calculate this angle. So for this angle calculation you have to consider this triangle. Okay, in that case this will be the base and this will be the height, because we calculate this angle. So in this case base will be 2 units and this height also will be 2 units. That means this angle is 45. If this angle is 45, then this above angle, this also is 45. That means this 5p1 will be 180 plus 45 is equal to 225 degree. And this 5p2 is actually shown wrong. 5p2 should come from here. So this 90 plus this angle. Okay, so 90 plus this angle, it will be 5p2. So how much is that? So in that case, this will be the height. So this will be the height. How much is this height? This will be actually 2 units, because this is -1 and this is -3. So this height will be 2 units. And from here to here, so this distance from real axis, it is distance of 3, and from here it is 1. So this is 4 units. That means this angle will be actually tan inverse of 2 by 4. Okay, so here this is 2 units and here this is 4 units. So this angle will be actually tan inverse 2 by 4. And that we are finding it to be around 26 degree or so. I don't know exactly tan inverse 2 is how much. So tan inverse 0.5, not 2. So this height will be now 2. This will be 4. So this angle actually is tan inverse of 2 by 6. Sorry, 2 by 4. In that case, whatever comes, that has to be added with 90. Okay, so this angle comes to be 116 degree. So total from here, poles are making angles 225 plus 116. Okay, so that's why this 5p1 plus 5p2 is equal to 225 plus 116, and this angle actually is equal to phi z. This is actually 90 degree. So 225 plus 116 minus 90 is coming to 251. And what is actually the phi A angle of arrival? For angle of arrival, it is 180 plus. So this is another new thing you are finding. For angle of departure, angle is 180 minus 5. Calculation of phi process is same. So for angle of arrival, it is 180 plus 5. So you're finding that this angle is 431. 431 is nothing but 431 minus 360. Okay. In that case, how much is the angle? 431 minus 360. This is minus 431, or you can say 431 plus 360. How much is that? So around 71 degree or something. That means you have to draw a line which is 71 degree from here. That means we'll leave with this point with 98 degree angle, and will come here at 71 degree angle. Okay, so that is the angle of arrival and angle of departure. And for here, this is minus 71 degree. Okay, so what we're finding here then, we are finding that for this case, angle of arrival for this top pole is -1 plus j is 198.43. For the bottom, angle of departure is minus 198.43. For the top zero, for the top zero, the angle will be around 71 degree positive. This is the angle of arrival, and for the bottom thing, it is minus 71 degree, that is angle of arrival. So all the same things, if you just, there is no crossover, I told you previously also, because the root locus is totally confined in the negative side of instrument. So in this case, this is how the root locus is to be drawn. So you just draw an angle of 198 degree from here, so it comes from here, it bends, and here also you have to draw a line, it's called as 71 degree, and this between 198 to 71. So this is confined from angle of departure, and this is the confinement angle of arrival. So between this 198 degree angle and 71 degree angle, the root locus will be confined. Same thing below. So same thing below, the angle of departure will be confined with minus 198 degree, that is above this line. Okay, and angle of arrival will be the right side of minus 71 degree line. So this is minus 71 degree like this, and this is minus 198 degree like this. So the root locus will be confined between minus 198 degree from the pole up to minus 71 degree to the Z. Okay, so this is these are the only details you have to find here. So in the whole numerical, only we have to find out what is the angle of arrival and what is the angle of departure. So still I find that students will not understand it easily. So this I will add, okay, one more page where I will do this angle of arrival calculation and angle of departure calculation, and I will post with this PDF. So this PDF will be there, and with that another single page will be separately attached, where I will calculate all the angle of departure from this pole 1 and angle of departure with, angle of arrival with pole 2. So this is very complex set of numerical where there are two imaginary poles and there are two imaginary zeros, and how to calculate the angle of departure from the imaginary poles, and how to calculate the angle of zero and arrival to zero, complex zero, that we will see in this case. That